So, welcome back. I was in the middle of explaining or giving a semantic theory of word classes, and I had covered more or less the nouns. And nouns are then based on my distinction between the properties and concepts. So a noun typically has several meanings in several domains. Now I'm going to turn to adjectives, and then I rely on this notion of a property because my simple idea is that an adjective is actually expressing a property, has information in one single domain. So this is what separates adjectives from nouns in general. Adjectives have two communicative functions. One is just as modifying a noun, as helping in identifying a reference. So if I ask you to bring me the book and you say, which book? I say, the red book. I mean, it's an addition, a specification of the noun phrase. And then the second is informative. You can say the book is red or the stove is hot. So these are two uses and they have slightly different syntactical properties, but I don't want to talk about them. So these are the main uses of adjectives. And my semantic recipe for adjectives is the following one. What I call the single domain hypothesis for adjectives. The meaning of an adjective can be described as a convex region in a single domain. Once again, the convexity, once again, the domain notion. And this has some fairly strong consequences. So the convexity means that there is no adjective that means green or orange. There could be color words meaning green or blue, and some languages have this kind of covering green or blue. But there is no language that has a color word that means green or orange, because that's not a convex region. And as regards the single domain, there is no adjective that means long and hot, because that would be covering two different domains. So actually this semantic hypothesis for adjectives has fairly strong consequences for what adjectives you will find in different languages. And I put this forward. I mean, it's an empirically testable theory, and there has been some discussion about it in the literature. But let's have a look at the color words. So there is a world color survey. You go around ask people speaking different languages, showing them color ships like this. They're called the Mansell color ships. And you ask them, what is the word in your language for this color? And you have, I think it's about 110 languages where you have data for this. And Gerhard Jäger, whom I also mentioned yesterday from Tübingen, he had taken this data, the data from the World Color Survey, and looked at what areas of the color space they cover. So he went through the data for 110 languages, and he found that now basically 94% of the data could be explained by saying that the color regions covered by the terms in these languages are convex. And the reason he didn't get 100% is basically that for many languages they only have one or two informants. And then you get a lot of statistical noise, basically. So for me, this is a very strong result, saying that in almost all known languages, languages where we have data for color words, the color words cover convex regions. Some languages partition color space into two words, dark and light, basically. Some have three, they add something like what we call red. Some have four, and so on. There are lots of variations of how you partition the color space in different languages. But the general rule is that in any language that we know of, the color regions are convex regions. So this is one piece of empirical support for this kind of and you can go through any kind of adjectives where for many domains we may not know the underlying structure well enough to test the convexity hypothesis. But for some, I mean, all the one-dimensional adjectives like hot and cold, you simply separate out a section of the line, and that's typically convex. So if something is called hot and something is called hot, and anything in between is also called hot, that seems very, very simple and convincing. There are some potential counterexamples. I mean, some say that ripe is really saying something about both the color and the sweetness or something. And it's a combination of different domains. Yeah, it might be, but I'm not so sure about it. We can also analyze it as a strong correlation between different domains. I mean, if you have the sweetness on one dimension and the color on one dimension, then there is a strong correlation between fruit being sweet and it being having a red color. And then you could say that the ripeness dimension is this line that is defined by the color. You're introducing a new kind of space here. You're using that correlation. That's one way of analyzing this problem. I'm not too worried about this example. Another example is the word healthy, because healthy involves a lot of dimension. I mean, not having pain, not having a high temperature, not having a high blood pressure, and so on. Healthiness involves a lot of different bodily domains. But what you get is in this time you have a lot of dimension, and basically you can look at being healthy as being close to the zero region of all these domains. So if you have a high value on any of the dimensions, you're not healthy. But the healthiness is the corner in this high dimensional space, and it would still be a convex region, even though it's a multidimensional domain in this case. So you can try to find counterexamples to my thesis, and we can discuss them. But still, this is a fairly strong cognitive constraint on what adjectives you would find in any language. Yeah, that's what I just said. Now, I told you I would. Okay, I'm sorry. This should have been earlier. This is nouns. I should have had this under the nouns. I promised to give the kinship relation. Come on.
How do you think about the counterexamples? Because I'm not sure if the convexity idea is necessarily like contradicting if we have this kind of combination of seemingly contradictory features. I mean, like one example in addition to those would be nostalgic, because that's usually interpreted as a combination of happiness and sadness. So it kind of contradicts the idea of convexity, but I'm not sure why it should contradict. Can't we have kind of this convexity rule as a kind of ground level or basic rule, but then in addition to that just pick up from that conceptual space certain features and make kind of new adjectives separate from the conceptual space?
And that's a new example to me. I mean, there are studies of the emotional domain, and emotions normally have two dimensions, positive, negative, and then arousal and calmness. Nostalgic doesn't fit into that space directly. I mean, it's a more complicated emotion, and I would have to think about how to analyze it. Maybe this combination of happiness and sadness is something over time. I mean, you're sad at the moment, but you remember your previous happiness, and that would make it's a more complicated phenomenon. I mean, I'm just improvising here. I have no idea how we would end up in analyzing the contents of nostalgic. Thanks for the example. I have to think about it. Sorry, I forgot to mention when I talked about nouns. This example, and this is an example from the Dutch linguist Joost Swartz. He analyzes you mentioned it, Christiane, the two dimensions. We have going back in time. I mean, this is mother, grandmother, great-grandmother, and then going down in time. And what he does, Jost Svart, is to just make a space out of these two dimensions. I mean, normally we think of them as one line, but his smart idea is to actually make it a two-dimensional space like this. And now I've only reproduce the female terms here. We have another layer with the male terms on top of that. So actually you should think of two layers of these terms. And then we can look at how different languages carve up this space. I mean, it's a discrete space. You have numbers of generations. But you can still talk about convexity in the number of steps here. So in English, you see that, I mean, aunt will be, I mean, independently of the number of generations, aunt will still be called aunt, even if you go to 4 or 5 generations. And in many languages, this term, sister and aunt, is one term only. So you have a line here that is a kind of convex thing. And in English, first cousin and second cousin are all called cousins. In many languages, for instance, in my native language, Swedish, we did make distinction between first cousin and second cousin and third cousin and so on. We have different terms for them. So, but cousin still turns out to be convex regions and so in here. And you can compare different languages, but Jost Svart has done it for a number of languages. And all kinship terms that, I mean, you don't get very many examples here, but still, they turn out to cover convex regions in this kind of space. Some languages, no, if you add the male terms, some languages like German and what else? French had make a distinction between the female and male cousins, and other languages don't. So you can have if you add a layer of male terms, you can have convexity, larger convex regions or smaller convex regions here. But basically, this is one way of organizing kinship terms that shows you that there is systematicity in how we apply the terms. Sorry about this. This is what should have been under nouns. Let's get back to the adjectives. Linda Smith has argued that when we start learning about words, children learn nouns earlier than they learn adjectives. And the reason is that they see some kind of correlation between properties. I mean, a cat has some kind of mixture of properties that makes it a cat, and it makes it distinguished from the properties of a dog. And then they are well organized by overall similarities. I mean, similarities across a number of domains. And then words that refer to superordinate categories, I mean, animal, are not well organized, so they are learned later. But the important thing for me here is that words that refer to dimensional relations, like being tall or red or old and so on, they are understood relatively late. And her idea is that you are, in your mind, in the child's mind, you're separating out the dimensions. I mean, you start with a holistic space. And then as you learn more domains, you learn about the color domain, you learn about the size domain, you're able to separate out these domains in your perception. Go ahead.
So I heard, I read these kind of claims a lot. You know, nouns are learned early, adjectives are learned late, abstract concepts are learned late. I've never seen any good evidence for this.
What
this is based on? There's this really good paper, I don't know, very recent. The 10 first words that are expressed in 3 different countries of children. They're actually pretty abstract, pretty non-noun-like.
Yeah. No, you're right. I mean, and among the first words are actually demonstratives. Here, I mean, there, that, or whatever. I mean, that's a typical one. But if you look at the 50 or 100 first words, I mean, there is data about this. And I don't have the reference in my mind, but there are fairly clear investigations on looking at the first 50 or 100 words that kids learn. And of course, you're right, that some of them are like greeting words, hi or bye or good night or whatever. I mean, these kind of social interaction words, they're quite common as well. But if you look at the classes I'm talking about, I mean, nouns and adjectives, then basic nouns come earlier than most adjectives. Of course, abstract nouns come later and so on, but if you look at the frequency, then it is really true that nouns come before in general come before the adjectives. There is a mixture, but in general, yeah, Christiane.
If I may make a supporting argument, is that we know that there are simply more nouns in the language too, and a sentence contains typically one verb and at least one noun.
Yeah.
So kids also have more exposure to nouns.
So your argument would be to say because the nouns are more frequent, sure. But I don't think it's a question of frequency. And
I'm just saying it's a possibility.
Yeah. I don't believe in that, and I'll give you some argument for it in a minute. Yeah, go ahead.
Well, just that in speech pathology, so our job is to figure out if kids are producing language as they should. So we have tools that have been standardized. Like one of them is called the MacArthur Bates. That it's like a checklist that you give the parents, and so we can tell, the parent for younger kids, like 18 months and probably 12 months to 2 years, I'd say, they're able to check what the child says, and there's like ranges of what's typical for English at least. So I'm sure other countries have something.
And what is the result?
I mean, there's a whole manual that we score on of things, but I mean, it is mostly nouns. Although we do, like in English, we have a lot of times people want please or thank you, or there are some other things as well. But
yeah.
There's like a whole list of things in frequency.
Yeah. I mean, we don't have to get into the discussion here, but the only point is that, is Linda Smith's point about we are starting with a number of dimensions and then we're separating out them in our minds in a while. Do you want to say something else? Or?
Final point. Also, this is all about like expressing linguistic sense, right? Like you're talking about concepts. So
sure. No, that's true. I mean, okay. I don't really need this data about nouns, and it's just as kind of support. I'm talking about concepts. You're right. So let's continue on the point. I mean, the child learning is not that important here. Now, my argument is that a 4-year-old, you can tell a 4-year-old the meaning of odd color terms like chartreuse and mauve and so on. I mean, they are not very frequent in language. And you can say that chartreuse is kind of yellowish green and mauve is kind of light violet or whatever. And then they will understand it. They can identify the meaning of these words. They're not frequent in language at all. Then if you try to tell them about words like inflation and mortgage, they are very frequent words, unfortunately. They're very frequent words in language. They will not be able to understand that. What is the inflation or what is a mortgage? Because they don't have the conceptual domain available. They have the color domain available, and you can add new concepts, you can add new regions quite easily because we are sharing the color domain with the kids. So this is an argument against looking at frequency. They are able to understand this and learn these words quite quickly if you just tell them. So my point here is it depends on sharing the semantic domain.
Just a quick point on the frequency, but they're not frequent in child.
No, not at all. But they're probably frequent. I have no data here in what parents talk about. So that would be the point. They hear these words quite often in their environment. But of course, they're not frequent in child interaction because the children don't have possibility of understanding these words. We are not sharing. And parents are quite aware of, implicitly, what the children will be able to understand and not understand here. So for kids, money is bill and coins. I mean, that's what it is. Or maybe credit cards nowadays. I mean, that's what money is. But it's not, that doesn't explain these words. So sharing domains is important. There are databases. The English Child is one that has collected a lot of children's speech. And I had a colleague who wrote a program where you could elicit the frequency of different words. So if you look at fruit words, and this is the age of month, and this is the frequencies, this is occurrences in 1 million tokens. So you see that 12 months children start to speak, and then suddenly the frequency goes up. It's not very clear for the fruit words, but you see that at least the word apple becomes very frequent when there are 18 months. And there is a bit of an increase here as well. Then the frequency goes down because children learn many more words. So they still know the words, but they are not as frequent anymore. But my point here is that if you look at the curves, all the fruit words are learned somehow during the second half of the second year. But if you take another group, more abstract words like alive, live, die, and dead, they are very infrequent until you get up till about 3 years of age, and then suddenly they increase. So when they are between 3 and 4, they learn to understand the difference between being alive and dead and so on. Then they can start talking about it. And we've done a little bit of running experiments, and it seems that there is some support. I mean, we don't have very strong support, but some support for this, what I call the establishment hypothesis. If one word from a domain is learned during a certain establishment period, then other common words from the same domain are learned roughly during the same period. We've done experiments on this on contrastive adjectives. So if you learn cold, you learn warm. No, if you learn warm, you learn cold. If you learn cheap, you learn expensive. And it turns out that there are fairly fixed intervals where you learn these contrastive pairs. So once you understand what cheap and expensive means, you get the domain. You learned about the domain of prices. And all the words, I mean, in this case only the contrastive adjectives, are learned basically during the same period of development. There is a very strong correlation between learning one pair of the adjective and the other pair of the adjective. And that's some support for that kids don't learn words in isolation, but they learn to understand new domains. It's not published yet. We have this. I mean, yeah, I have some stuff in my book. I mean, the first this, and you can play around with the program is publicly available. I can give you the link to how to get to this data. But this study on the adjectives is recent, so we've submitted it, but it's not published yet. So, but I can send you the manuscript if you want to. This is studies on Swedish children, Swedish adjective pairs. Okay.
Excuse me. Here, learn means they see use correctly.
Yeah. The typical in this case, we studied, or my colleagues studied 3 and 5 year old Swedish kids, and they said if a thing is not warm, what is it? And they were supposed to answer cold, and then you got the right score. So that you just elicit the opposite. Standard situation. You ask for the opposite or opposite meaning. Yeah.
So it's not challenging like it was.
No. This is a very simple situation. Okay, that's adjectives. Now we go to verbs. And before I talk about verbs, I have to say something about how I model actions. So let's talk about actions. And we perform actions, we recognize action, we can immediately tell whether somebody is running or walking. I mean, the difference in motor pattern is not very different, but we still see the difference. And action space has some structure. We can talk about similarities of actions and so on, but we don't really know how to describe it. Earlier I already mentioned Marr and Weina's attempt here. I mean, Marr described shapes in terms of cylinders But they, together with Weiner, he also tried to develop some kind of model of actions. They didn't go very far. And later there has been some studies of it, and now I want to try to show you a movie, and it's a bit of a trick here because I want to show you only 200 milliseconds. Maybe you can see what this is, but it's probably, hopefully it's difficult, so let's see if we can do it. I'm sorry, I couldn't stop it. It's too long. But I mean, there have been experiments on this. I mean, basically, you see these black and white dots, but it's been shown that within 200 milliseconds, a fifth of a second, you identify not only that it's a human, but what the human is doing. This is based on experiments from, this is a tough one. I mean, you can see it's a basketball throw. I mean, yeah. So, and the point of this is that you get very little information about this. I mean, you don't see the body shapes. You only see, well, the black and white dots. And the originator of this is Gunnar Johansson, a Swedish psychologist, who in the 1950s put light dots on the joints of a human. And they dressed up the human in black and filmed the person in a dark room. So the only thing you see on the movie are these dots. And then he showed that given 200 milliseconds, you can identify the action the person is performing. The point is that you strip away a lot of information. Nothing about the shape, nothing about the color, basically nothing about the size, because you don't see how far away the thing is, and so on. And this information is sufficient that our brains extremely quickly picks up an action. So my idea, no, it's not my idea, but it comes from a student of Gunnar Johansson, Sverker Runesson, who says that the kinematics, I mean these dots that we see, they contain sufficient information to see the underlying dynamics of force patterns. So there is a variation of an experiment. You dress up a person with the patch lights, and then the person is lifting a box. You don't see the box on the movie. That has no trace on the movie. And the box weighs between 2 kilos and 20 kilos. And the person that is filmed is lifting this box. Then the subjects who are watching the movie are asked to estimate the weight of the box. They're accurate within a margin of 1 kilo to estimate the weight. You can see by the way the body is leaning and how the arms are moving and so on. You can see how heavy the box is just from the movement of the body. We pick up the forces extremely quickly. So my idea here is that, and that's the representational hypothesis, that the fundamental cognitive representation of action is a pattern of forces. Now I talk about bodily action, where we feel the forces of our joints. If I'm running, I'm doing a different force pattern than if I'm walking. There are some differences in how I move my legs and how I exert the forces of legs and arms and so on. And we can distinguish these force patterns very, very, very easily. So I want to introduce the domains of force. And in particular, well, it's more complicated because it's a pattern of forces to analyze actions. And of course, there's not only biological movement, that is movement of people and animals, but there are all kinds of movements. And we pick them out, we identify them by the forces that are underlying the movements. So this is my analysis of actions here. And we can judge similarity. I had a former PhD student who did this, and you get exactly the same kind of prototype effects with actions as you do with ordinary objects. You get precisely the same results as Eleanor Roche got for objects. So you have prototypical types of walking, and you have odd types of walking. Some of you may remember Monty Python's The Department of Odd Walks. Okay. So, and again, I would define an action category as a convex region in the space of force patterns. There are very many ways of walking, but if you take one way of walking and another way of walking, and then you perform something in between, then that would also be called walking. Nowadays you can do this with morphing methods and test this idea, and it's been tested in some areas, and there is quite strong support for this convexity idea of force patterns.
I think I missed a point. So you said we recognize actions with kinematics.
Yeah.
Which is, there is no forces.
No.
Then the space is based on forces.
No.
The point here.
The perception is kinematics. You see the moving dots. But our brain is a good Newtonian brain and takes the second derivative of it. So we represent the actions. We identify them via the forces. So there is a process in the brain that transforms it from the kinematics to the dynamics.
Yeah, but why not saying that the space is based on kinematics? It's said from now moving into dynamics, which is much more complicated.
It's not more complicated. You can go from the one to the other. No. I mean, my point is that when we do categories, we do it on the forces, not on the kinematics.
It's based on is there some research?
Not very much, but there is no, I mean, there is this kind of, I can point, I mean, if you look at the Gunnar Johansson stuff, there is support for this. So, to give you one example, if you see two dots moving in an elliptical pattern, I mean, they're moving in an ellipse, it's a very strong perception. You see it as a circular disk, but it's tilted. So you don't see it as two dots moving in an ellipse. You see it's a circular disk, and that is the solution that minimizes the forces that's acting on the dots. So that would be one simple example showing that this is the solution of these dots that would minimize the forces involved in the system. You follow me?
So you give an explanation why I see a disk
Yeah?
out of two moving lines.
Yeah? The explanation is that perception is the one that minimizes the forces involved in the movements of the dots.
Is it the only explanation that does?
I'm not sure it's the only one. It's not maybe there are other explanations,
my
but
next question is: if you take the kinematic space, do you still have the convex region coming out from
this is tough to test. I mean, empirically, there might not be very large differences between these two models. I mean, I'm giving you this one because here you have a clear case. The kinematics is the things move in an elliptical way, but our perception is that there are two dots move on a circular thing that is tilted. So, I mean, that's a support that we are trying to minimize the forces that are involved in the process. And there are lots of examples from Gunnar Johansson's experiments showing this kind of phenomenon. Yeah. Okay. Yeah. Now we get into verbs, and I'll get back to that in a second. I want to say a little bit more about actions before I get to it. But there are two kinds of verbs, and one type of verbs express actions, like hit or run or beat or whatever. And then lots of, or push. And then other verbs express the results of actions, like move or heat or paint or whatever. And I'll get back to that distinction in a while. There are other explanations of how forces are used in understanding language. And the famous case is Talmad's article on force dynamics. But he only considers cases where there is an interaction between two actors, what he calls the agonist and the protagonist. So he has saying that the ball kept rolling despite the stiff grass and so on. I mean, there is the ball and there is the stiff grass, and there is the interaction between the forces of the ball and the forces of the grass. So he introduced the force dynamics, but he has a limited area of application. Then a lot of people we've heard Barcelo and others here, work with embodied cognition. But then you are focusing on the impressions on the subject. I mean, how the subject relates to the world and so on. I want to generalize and say that this force pattern is independent of, it's for single objects, but it's not only for me, but it's for all objects in the world. And of course, sometimes we have interaction between two objects, and then we have to take this interaction into account. But I mean, I want to rely on a more general notion of force dynamics. And I really think that the role of forces in semantics has been underrated. I mean, there are people like Talmi, and then there is the group of embodied cognition, but they only do limited areas of application. It's a general complaint here, but well. Then, from actions, I get into events. What is an event? Well, there are lots of theories of events. And in philosophical literature, they have metaphysical analysis. I mean, for those of you with a background in philosophy know the works of Davidson and Kim and so on. That's an analysis that is kind of independent of cognitive processes. I want to have a cognitive theory of events. So I want to give a model that accounts for how events are mentally represented. And then there are linguistic theories of events. I would say that they are often confused here. So to give you one example here of how events are described, this is a formula or an expression from Jackendorf. But people like Beth Levin and others also use these kind of expressions to talk about meanings of verbs. So the meaning of break is analyzed that there X acts, this is somebody, acts in a manner to cause something, Y, to become broken. So action to cause something to change a property, to become broken. That's the analysis of the verb break. This is an event of breaking here. What I don't like about this analysis is that this word broken. You reduce break with broken in square brackets here and big letters, capital letters. But we don't really understand what is meant by broken here. I mean, it's a little bit like putting the cart before the horse, but it doesn't tell you very much about what goes on here. I want to get out of this kind of symbolic representations of breaking. So together with Massimo Vaglian, I developed a two-vector model of an event. And the model is very simple. It looks like this. There is an agent, it's not always obligatory, who exerts a force, who does something to a patient, another object. And as a result, something happens to the patient. I mean, the result is some change in the patient. It might be the location of the patient, it might be some other properties of the patient. These are all the components, basic components of the model. So the force vector acts on a patient, or a force pattern if you like, and this comes then from force space generated by an action. I already said this, it describes the changes. And of course, sometimes there is no change. The result vector is nil, nothing changes. Then it's a state. It's not, I mean, in a state is a particular case of an event where the result is that you remain in the same position. The vector is nil. So this result can be a change in location in space, or it can be changed in the properties of the patient. It can become warmer or older or bigger or painted and so on. It can change properties. And sometimes there are forces that don't need an agent. So I mean, sometimes when you're falling, there is gravitation gives the force, and when you're growing, the force comes from inside you, and dying, there is nothing. So we don't always need an agent. There is always a patient needed for an event, and there is always a force vector, and result vector may be of different types. This is the model of an event. Now here is a simple example. This is the patient. This is the agent. I'm sorry, try the other way around. This is the patient. This is the agent, sorry. This is the patient. This is the force vector. You're pulling up the hill here. And then this is the result vector, this sled changing its position. And because of gravitation, the result vector doesn't have the same direction as the force vector. This is a simple example here. And of course, this is in a sense also a model of causation. The force vector is the cause. The result vector is the effect. So events involve a model of causation. I mean, the force vector gives the result as a cause. There are other theories of events. There's a book by Radwanski and Sachs that's called Event Representation. And they are more interested not in the internal structure of events. They're not giving a particular, but they are very much interested in how events are segmented and how you define the borders between events. So what we do, in contrast to Sachs and Radwanski, is to give the internal mechanics of an event. We don't work that much on the borders between events. So there are two different traditions of event representation here. So agent and patient are typical what linguists would call thematic roles. An agent is represented in agent space. I mean, it's an object, could be an abstract thing, but it's something that is typically expressed by a noun, but it has to be able to exert a force. Otherwise, it can't be an agent. And then the patient is some kind of object, and typically in physical space. But we can also have other thematical roles. I can hit a window with a stone, and then the stone is an instrument. That's another role. And then the instrument is transferring the force to the patient. Or I can I can slice a bread with a knife. Then I'm using the force of my hand is transferred to the knife and is making is cutting the bread. And you can have counter forces. Like gravitation. Like friction or like somebody resisting a push or whatever exerted by patient or others. The agent can have been intentional agent. I forgot to mention you can also have recipients. I mean, if I'm giving you a flower or giving you a cake, there is the agent and the patient. The patient is the cake, and then there is the recipient. You can have three roles involved as well. This way it makes the events a little bit more complicated. But the basic model contains the agent and the patient, the force vector and the result vector. In the analysis of thematic roles from linguistics, the force and the result vector normally don't show up. So this is a very simple, but I will try to show you. It's a rich model of events. No, okay, go ahead. Yeah.
Sorry, I want to understand what you have in mind when you say event. So, assume I have a child and I just play the guitar, right? He has no connection between the movement and the sound. Is it the child perceive an event or not? Because he has no connection with the force here, right? So I'm not understanding if this case is within your theory or is out of your theory.
No, of course. I mean, your movements result in a sound. That would be
That's what I know, but not the child. The child hears the sound. He has no idea of the connection between the
No.
Yeah. Yeah. So if you lack the connection, you don't have the connection of the forces.
Yeah.
And then you don't have an event according to your theory. That's what I understand.
Yeah, sure. I mean, the child can press a button for a light, and I have no idea how pressing the button of the light turns on the light. Okay. But still, it's an event.
Is it one event or two events? The connection there is important, right? Because the forces are.
No, it's okay.
If you know the forces.
No. There are two events. There is you playing the guitar, and there is the child hearing the sound.
Okay, but hearing, there is no force there, right? You don't understand acoustics, I believe. which is concrete, right?
Yeah,
so
yeah.
Where is the event? You have enough force there. From the point of view of the child, which is perceiving the event.
Yeah. No. I mean, there is a force. There is a sound coming, and it's. I mean, I don't. Okay, I should have said that forces need not only be these physical. I mean, standard forces. I can have emotional forces as well, and yeah. Okay. Yeah.
No, of course, we know physics. We know physics, but the problem is there an event for the child? Because if you have a cognition there, you need to have the agent. The agent, the perception here is the child. He has no knowledge about forces.
There are two events.
Where is the event if you need the forces?
You don't need to know the forces. You don't. No. The event is. You don't have to have. I mean.
So this is an objective event. It's not a perceived event. It's what is there in reality, not what I understand as a cognitive agent.
Yeah.
Is that correct?
There is. Okay, I should be a bit careful here. You're right. There is a perceived agent of you playing the guitar. Perceived event of you playing the guitar. And the child sees the movements, the child doesn't understand how the movements cause the sounds, but there is the result. And then, of course, there is the perception, the other event of hearing the sound. That's another event. And then the child has no idea of how the sound gets, but it would be an event.
Just to make sure that I understand you, so a few minutes back you were criticizing the linguistic approach in terms of symbolic representations.
Yeah.
So how would an event like breaking be represented in your approach? What is the result?
Okay, breaking. I will talk about different verbs in a second. But breaking would be that there is a force. It can be any kind. There are lots of kinds of forces. Breaking is a result verb, talking about what's the result of something. And the result is that one object is turned into two objects. So it's a kind of it's a bit of an odd change of an object of the patient. The patient suddenly becomes two pieces. That's breaking, or more pieces. Yeah. And some of these questions I hope will be better answered when I give you examples of how verbs function here. Was there any more question? No. Okay. Let me go on to. Yeah. No. My question is, of course. Sorry. I should ask you the question. What is the meaning of a sentence? Now, I gave you the solution already, but anyway. So, what is the meaning of a sentence? In an ordinary sentence like, I broke the window, or whatever.
It's a tough question.
Yeah, a tough question. In philosophy, I'm complaining against analytic philosophy again. From Frege, it said that a sentence expresses a proposition. And a proposition has the content of a thought. That's what Frege says. So what is a thought?
But a sentence could be not just one proposition. It could be like two propositions.
Yeah, sure. But a basic single sentence. Yeah, no, it could be several propositions. It could be complicated. Do you want to answer the question, or you have some other comment? Yeah?
I thought it's a proposition.
I'm sorry.
I would say it's a proposition.
Yeah, but Frege says that a proposition expresses, has the content of a thought. That's what he says. So, for me, this notion of a proposition, this notion of a thought, are kind of vague, and you never get out of this and then in development of logic, a proposition has been identified with a set of possible worlds, so the meaning of a sentence is a set of possible worlds. Yeah, that's one way of answering, but for me that's very abstract, and it doesn't tell you very much about what goes on in our minds when we understand the meaning of a sentence. You first, and then you. Yeah.
Okay, according to Kinch models and stuff, proposition could be argument and set of arguments, and the predicate. This is the meaning.
Yeah. And I'm getting to that kind of picture here. Then the arguments for me are these components of an event. And then the predicates I divide into properties and concepts and so on. So it's along that line. But I think I fill in more of the contents of what are the arguments and the components here by having this event model.
Well, you can also think about proposition in a Russellian way and think it's some kind of actual stuff in the world. So I don't think it could get any more concrete than thinking about propositions.
Yeah. But actually, actual stuff in the world, I mean, that's, in my mind, also a bit vague. And most of the propositions that philosophers deal with are static. The classic one is Tarski's "snow is white," if and only if snow is white. That kind of perspective would have problems with dynamic actions and things like that. They don't give a good answer to, in my mind, to how we understand sentences that involve actions or propositions. Yeah, but I mean, yeah. Okay, I'm complaining a little bit about here, but my answer. I mean, let me give you, not be critical, but be constructive instead here. To me, the meaning of a sentence is an event. Could be a state like snow is white, but a sentence expresses a part of an event. An event can be very rich. I mean, like playing a guitar is a kind of rich event. But it involves at least a force and a result vector and one entity. It could be the agent or the patient. So it contains two components from the event model. One vector and at least one entity. It can contain many more things here. So when you express a sentence about something happening in the world, you focus on something. You focus on the agent, you focus on the patient, you focus on the force vector, or you focus on the result vector. And depending on where your intention lies, you will construct different sentences. And linguists calls this a construal. You pick out the elements you want to talk about. So just to give you an elementary example, the sentence Victoria hits Oscar. In this sentence, Victoria is made subject, and you put the emphasis on the agent here. But in the sentence Oscar was hit by Victoria, you put the focus, you make Oscar the subject. In the European languages, the subject is the thing you attend to. And they are made subjects. But in this case, Oscar is the patient and Victoria is the agent. So that means that there is, in the European languages, there is no simple relation between agent and patient and subject and object. Typically, we put subjects as agent as subjects, but it's as I show here, this is not necessary.
What about the snow is white? So where's the sentence the snow is white?
This is the snow is the patient and white is a state. It's talking about a constant result vector being white.
So we count as also agents.
Yeah, it's a state. I mean, I have states as a particular case where the result is no change. It's being white is what it is. Yeah.
So the force vector here is like null vector. If we have like states.
Yeah. The result vector is null. You can have. I mean, if.
And force vector.
I'm standing here. I mean, I'm standing fairly still, but I'm balancing against all kinds of vector, and I'm counteracting gravity. So you can have a nil result as a balance of different force vectors. Yeah.
What is the force in 2 + 2 is equal 4?
I'm sorry.
What is the force in the sentence 2 + 2 is equal 4?
There's probably, yeah, okay. Now we get into abstract concepts. Yeah, sure. No, I mean, I have to think a bit about that if I can find a force.
Leave it clear that I'm equal to myself.
First of all, this is a state. So the question is, so it's I don't need a real force here. I mean, there could be null forces as well. I mean, yeah. There can be null forces. That's yeah.
Like it smells good. So
Yeah. No. Okay. Now I want to apply this to represent verb meanings. So I again give you a theory of word meanings, verb meanings that says that the verb is a convex region of vectors that depends only on a single domain. And now it's a convex region of force vectors, as I said before. So here are examples. Push is a force vector of an event. I mean, I'm pushing something, and it refers to the force domain. Move is a result verb. It refers to changes in the spatial domain the thing moves from point A to point B. And heat refers to changes in temperature. So again, like with adjectives, I'm putting forward a fairly strong empirical hypothesis here, that verbs depend on a single domain. And this is even more controversial. I mean, linguists have been discussing this for a long time. But I still believe it has a content. So there are no verbs that mean walk and burn. That would be multiple domains. And there are no verbs that mean crawl or run. I mean, there might be verbs that mean run or walk. That's possible because then they are similar. But crawling and running are disjoint in for space. So there wouldn't be any verbs like that. So that's another empirical prediction here. I can talk about a lot of predictions from the theory. How much time do I have?
5 minutes.
5 minutes, okay. Let me go through the verbs. I can talk about similarities of verb meanings. And Christiane had this example of different, in English, being very rich in verbs for walking. I mean, you had another list than I have. I mean, there are lots of verbs for that. And they are all sub-regions of walking. They're the special, you march with stiff legs and whatever you do in the other styles here, I don't know. They are sub-regions. And you can say that because the force patterns are then sub-regions of the more general pattern of walking. It can explain metaphorical uses of verbs. Her intelligence hit me. I mean, now it's a kind of mental force. I feel like I'm hit by the personality of somebody. Slicing a backhand. I mean, slicing is normally used for cutting bread. I mean, you're separating something. And when you slice a backhand in tennis, you move your racket in the same kind of fashion as if you're slicing bread. And scything down a football player. I mean, I don't know if all of you know what a scythe is, but it's kind of instrument. And that means that another football player is using his leg as a scythe to cut down the first player. So verb metaphors have not been studied very extensively, but I can explain how they work by saying it's the same force pattern that is involved. Even if the objects are totally different, the force patterns are similar. So that's my way of explaining verb metaphors. Sami.
Have you considered in relation to this also modal verbs such as must or
I have considered them, but I don't have a good theory yet. I mean, there is a lot of history about the development of modal verbs from Yves Switzer and others, but I haven't developed that. Some of them have a metaphorical root, yes.
Where do creation verbs come in? So slice a backhand. The backhand is arguably not patient or affected because it's right. So I just want to clarify your general theory. Is something that is created, I bake a cake or something, also a patient or affected or
Yeah, verbs of creation are like the opposite of verbs of breaking. I mean, before the event there is no patient, and then afterward there is a cake. So you're introducing a new patient in the. These are a little bit odd from the event theory.
To me, I don't want to get into. To me, a patient usually is involved in the entire course of the event, whereas a creation is only at the final stage.
Yeah.
You don't slice the backhand during every interval of time that you are.
No. In baking a cake. No, the patient here, the cake, is this is an intentional event. I mean, I talked about intentional things. So you have the intention of creating the patient, but the patient doesn't exist at the beginning. But it's it's an intentional verb, and I'm not sure I have time to talk about intentional verb. Yeah. Linguists make the distinction between manner and result verbs. I get that for free by having manner verbs being mapped onto force vectors and result verbs mapping onto result vectors. And yeah, as I said already. So let's give you an example of a manner verb, like push. So there is a force applied to an object. Prototypically, push leads to a change of a position of an object, but there are exceptions. There is a counterforce here, and we tell that. Then we talk about exceptions with sentences like, but he pushed the door, but it didn't open. It's against the expectation of the result. Then we take result verbs. I've picked this. This is describes a change in an object. You can open a door. It's a change, growing a plant, paint a house. And I picked this picture because you can't see how it's painting the house if you're using a brush or a roller or a sprayer. But what's important here is that the color of the house is changing. You can't see the manner, but you can see the result here. And they don't determine the forces that lead to the change. And you have two basic kinds. I mean, change of position in ordinary space and change of properties in category spaces. Here we get to hearing, by the way. So I hear the owl, I hear the guitar music. Then I am the patient. There is something impinging on me. I get a perception. My result is hearing something. You can distinguish that from I listen to the owl. Then I'm the patient, and I'm actively attracting. I mean, I'm exerting my. Now, the force is actually attention here. I'm attending to the sound of the owl. Then I'm the agent. English has pairs of verbs for the perception verbs. I see, I look, I hear, I listen, I touch. No, there come up other pairs. And these are mental verbs. I mean, I try to change your stage of mind. No, I'm sorry. These are result verbs. I scare you. The result is that you become afraid. I persuade you. You become convinced, and so on. So these are result verbs. They apply to different domains of the patient's emotional or cognitive space here. Now, you can ask, why do we divide verbs into either manner or result? Why don't we have verbs that do both? Yeah, to some extent we do, but there is fairly strong support for linguistic analysis. When I perform a force vector, I expect something. I mean, if I push a door, I expect it to open, but I'm not sure about the result. And there are very many ways of painting a house. But so there is no one-to-one mapping between forces and results. So we need some kind of division here. That's one reason. And we cannot learn the mapping from the forces to the results. So we need, this is climbing, different cases of climbing. By the way, this is you talk about an airplane is climbing. Here you have the forces or the pressure on the air. That's what's going on here. I think I'll skip the analysis of this as a possible counterexample. That's an example that's been discussed in the literature, but I don't have time to go into the details here. And state verbs, I mean, are things that describe things that have no change involved here. They are identity vectors. No force is applied. They are all result verbs, the state verbs. Okay, I should guess I stop now. And I'm sorry about the rush at the end, but I have given you now adjectives, an analysis of verbs in terms of forces or force patterns. I have a few word classes to go before I end, and then the final part in the afternoon will be compositionality. So, see you in the afternoon.